Hey guys, welcome to our channel. In this specific video, I would like to show you how to use Terraform to deploy pretty simple and straightforward configuration, which includes an S3 bucket and Lambda function integration through Amazon SQS service. Basically, we will let our users to upload files to an S3 bucket, and an S3 bucket will send a create object notification to SQS service, from which it will be picked up by the Lambda function, right? So to build this entire architecture, we will use a Cloud9 ID. In this ID, I already created a separate project folder, which is called S3-SQS-Lambda example. And basically, let's start building that project. So as soon as we are starting that specific project, I would like to create a separate folder for our Lambda function. So let's call it Lambda. And within this folder, I will create a file which is called index.py, which will contain the source code of our Python Lambda function. Next, what I would like to do, I would like to start forming or creating our Terraform project. So first of all, the first file which I'm starting from, I'm trying to define a backend configuration for the Terraform. In my specific case, I'm using an S3 remote backend. So let me to copy the backend configuration from one of the other projects which I already created. And what I'm usually doing every single time I'm configuring the backend, first of all, I'm specifying the actual S3 bucket for my backend, right? The DynamoDB table for object state locking during the Terraform code execution, and I'm changing the key file name to the project name. So let me to rename the project, copy the name from the project, and basically paste it here. So now the backend is configured. So for those of you who don't know what the Terraform backend is, basically it's the store for the Terraform state files, which are representing the actual state of our infrastructure. And the Terraform state files helps Terraform to understand what changes the Terraform should make as soon as we are making changes in the Terraform code and trying to apply these changes to the infrastructure. So as soon as the backend configuration is created, we may start creating the additional files like the one which I will create right now. The next file will be the file which will store the provider's configuration. In this specific file, I usually prefer to store any type of providers which I'm using in my Terraform code base. So in this project, we will use just only an AWS provider, and I specified here like provider AWS, and then we have to specify region. As you can see, I'm usually taking the region from the variables, and that's going to be our next file which we will create in our project. Within the variables file, we have to create a couple of variables. First variable will be called region, which will contain the actual region where we are going to create all our resources identified on this architecture diagram. That's gonna be US East 1 region. Let's leave it as is, and then the application environment variable. Usually, let me change it first. I will use the prefix of my website domain here, and usually the purpose of this variable is to use it as a prefix for all the names of all resources which we are going to create using Terraform. So, for example, in the environment name variable, we can store things like, for example, def environment, prod environment, prefix of our domain name, or anything else, right? So basically, using prefix as a part of the resource name will help you to use the same Terraform stack and to deploy the same code base across multiple different, let's say, AWS environments or any other environments in other cloud providers. So now, as soon as the variables and providers are defined, we can move forward and start defining our resources. And we will start defining our resources from the SQS queue. So the SQS QTF file will contain the actual resource of the SQS queue. Let me to show you how everything looks like. So we are using the standard AWS SQS queue resource. We are specifying the resource name. And that's exactly what I've been speaking about. We are using an environment variable as a prefix to have an ability to deploy it using multiple different prefixes from, for example, CI/CD pipeline. And then we have a specified policy for our SQS queue. And within this policy, we will let an SQS queue send message API call which is coming from our S3 bucket, which is not yet defined, and we will define it in a second. But basically, this policy allows to send messages to that specific queue from the S3 bucket ARN. Now, as soon as the S3 bucket is not defined, let's go ahead and define it. For that specific purpose, we'll create a separate file, and let's call it S3TF. But before that, we will save this file. And now let's create an S3 bucket, right? In addition to the S3 bucket, we have to create a couple of additional resources. First of all, the event filter, which will allow us to filter actual events which we are going to send to the SQS queue. So for our bucket ID, we will send an S3 object created event to AWS SQS queue, which we created earlier, right? And as soon as this event filter has been defined, we need to create a Lambda event source mapping, which will basically tell that we are going to process messages from the SQS queue by our Lambda function, which we are going to create in a second. Now, of course, this event mapping will be enabled, and we are going to process all these messages in batches, and every single batch will contain one single message. Next, we have to define the Lambda function. So for that specific purpose, let's create a new file and call it lambda.tf. And within this specific file, I would like to start building a Lambda function. First of all, we have to create an archive file data resource, which will help us to take the content of this Lambda function folder and create an archive and put it within the same folder. The type of archive will be zip archive. Next, we have to define a Lambda function policy, which will grant our Lambda function certain permissions. And let's walk through this AWS IAM policy. So the name and the description are going to be equal. and just contain the Lambda policy and the application prefix. And now let's review the policy itself. First of all, the first statement which we are looking at is the statement which will allow the Lambda function to get and put something to our S3 bucket, right? So this is very important. Otherwise, our Lambda function will not be able to get any information from the S3 bucket. Next, we need to give a Lambda function permissions to work with the SQS We need to give it permissions to receive messages, then delete messages, and of course get queue attributes. And of course, we are providing an S3-SQS ARN here as a resource, right? And the last statement is also very important. We will use it to give our Lambda function an ability to send logs to CloudWatch log group. So to do that, we need to grant the Lambda permissions to create log group, to create log stream, and put log events, right? So as soon as the policy or permissions for our Lambda function has been defined, we need to define a Lambda function role. The role definition is very simple and straightforward. It will consist of the actual role name and the assume role policy document, which will basically grant permissions to the Lambda AWS service to assume role, which we will provide as a part of the Lambda function configuration. As soon as the role is defined, we can basically, or we need to attach this role to the policy, and basically before, without this particular statement, we will just separately create the role and the policy, but this role and policy will not be associated with each other. So as soon as we associated the role with the policy, the Lambda function will actually get the permissions which we defined in our policy. And then we need to create a Lambda function itself. So for the Lambda function, we need to define the resource AWS Lambda function, and within this resource we have to specify the file name, which will contain the string of the path to our Lambda function zip archive. So as I remember, we had it in a little bit different form over here. So we'll copy this string here and paste it here. So basically we will look for our Lambda function zip file in the path related to our module in this specific folder structure. So the zip archive is going to be created here, and we will pick it up from here. The source code hash will basically tell the Terraform that the hash been changed every single time we're making changes in this specific index file, and the Terraform will redeploy the Lambda function upon its next execution. We are specifying the function name, the actual role which is coming from the from this specific statement, AWS IAM role. And finally, we are specifying the runtime. Let's use a new runtime, which is Python 3.9, and the actual handler. The handler is the index method, not the index, but the first method of the Lambda function, which will be executed as soon as the Lambda function is triggered. So the handler consists of the, should have be specified in the Python notation. So basically, we are specifying the index module, and the module will be the name of the index file itself, and the handler. And the handler will be method within this particular file. So now, as soon as we defined our Lambda function, the last thing which I would strongly suggest you to define as well is a CloudWatch log group. So basically, if you are not defining the CloudWatch log group in your Terraform configuration for Lambda function will create this log group automatically by itself. But as soon as you terminate or destroy the infrastructure through the Terraform, the CloudWatch log group will stay in your AWS account. And of course, what I usually prefer to do, especially for demo projects, is to specify the retention period on these, like 1 day if I'm forgetting to delete the Terraform stack, or destroy the Terraform stack later on, or like as soon as I will destroy the Terraform project, right, and delete all the resources, it will delete the Lambda watch CloudWatch log group for the Lambda function, and that will keep my AWS account nice and clean. And of course, I'm specifying the name for the CloudWatch log group using AWS notation, which consists of /AWS/Lambda and then the Lambda function name, which I'm taking from the Lambda function resource. Now, it looks like we defined everything except of the code for the Lambda function itself, right? So for the code base for the Lambda function, let's define something simple and very straightforward. So of course, let's create, so the first thing which we are doing here is we are importing a couple of embedded Python modules like logging and JSON. Then we are defining the logger. And then basically we're specifying the handler method. The standard definition for the handler method or main method for the Lambda function is the following. We should provide a couple of like variables over here, like the event and the context. The event object will contain any payload which the Lambda function will get during its execution from other AWS services. And it will contain all the metadata, and basically it contains the input for the Lambda function. So every single AWS service has a different event and a different event structure. And that's why I'm usually logging the incoming event for the Lambda function separately, right before doing anything else in the Lambda function. That's especially useful if you don't know the event structure, right, and or don't know where exactly to look for information in the event itself. So now, as soon as I executed that specific code some time ago, I know for sure that the event which is coming from the SQS queue contains a records key, and this records key basically contains a list of all records which I'm getting from the SQS queue. Of course, I will get just only one record, but in general, it's a good practice to use a for loop over here. So for every single record in this list, I need to get an S3 event, right? And the S3 event is basically provided as a string in the body of the SQS key event, right? So I'm using the JSON loads method to get or to convert the string to the actual S3 event, and then basically I'm logging this event, right? Afterwards, I'm ignoring the test S3 test event, which an S3 bucket will send to SQS queue from time to time. And if I'm getting a different type of event, I'm basically logging an S3 bucket name and the object key, right? But here, starting from that moment of time, you can do something meaningful with your object, right? You can use both the library to load it to the Lambda function. For example, if it is an image, you can convert it to another image, or like if it is a video, you can convert a video or do whatever you want with the objects which are uploaded to the S3 bucket. And of course, we are catching any exceptions using try catch standard try catch definition. Okay, fine. So as for now, it looks like we created everything we need, and it's a good time to deploy our Lambda function code, right? So to achieve that specific goal, we have to jump to the to that specific folder, S3-SQS-Lambda example, right? To our project source code folder, and execute Terraform init command. As soon as the Terraform init command is executed, we can start applying Terraform changes. And to do that, we have to execute Terraform apply, and then my preferable flag, auto apply, auto approve, just because, I mean, every single time you're iterating over the same Terraform code base and something is not working, it's very convenient to execute the same command and not be interrupted by providing the acknowledgement to the Terraform that you agree that Terraform will make certain changes in the infrastructure. So now that the changes the Terraform is trying to apply changes to my AWS account, and while the Terraform is doing that, we can go to console AWS and basically go to the S3 buckets, and our S3 bucket should already be defined, and it's over here, hands-on cloud S3 demo bucket. Cool. And as soon as we finish deployment in a couple of seconds, we will upload something to this S3 bucket and check the Lambda execution logs. Okay, so let's upload random file. Let it be my logo image. Let me to upload it. Close. So the S3 bucket contains the actual file. Now let's go to the Lambda function. And from there, I'm usually using this view logs in CloudWatch to jump to the required CloudWatch log group. And here we already got a log stream, and let's check it out. So what do we have here? So as you can see, we got an SQSQ event, then we got an S3 event, which is an S3 test event, and then we are ignoring it, right? So then, as you can see, we got another event from SQSQ, and here we have a real S3 event which contains an information about the uploaded file. And afterwards, we are printing a couple of additional statements about the actual S3 bucket and the object key. So at this moment of time, I think that we successfully deployed a Lambda function, S3 bucket, and SQSQ from Terraform. And in next video, I would like to show you how to test this specific Lambda function source code using Moto library. Stay tuned.